Hi, my name is Homer. Welcome to another Math 23 discussion video. For today, we'll be discussing directional derivatives, gradient, and tangent terms. This is part one of two videos for this topic. Okay, so ayun nga, I suggest na itong nakasulat dito na set of exercises, please answer on your own first kasi mag-proceed na agad tayo dito sa solution for each. Okay, so you can pause the video if you want to answer on your own first. Okay, so let's start. Number one. Yun. Okay, so number one, we need to find the directional derivative of f at the point P along the indicated direction. So number one, meron tayong f equal to y e to the x and the point 0,2 and the vector equal to negative 1, 1. So to get the directional derivative of f at the point P along the indicated direction, gagamitin lang natin yung formula na ang directional derivative ng f at that point, number one, ang point ay 0,2, no? This is equal to the gradient of f evaluated at 0,2 dot product with the unit vector in the direction indicated. Okay, so let's start with the gradient. So we have fxy is equal to y times e to the x. So ang gradient ng f of xy is equal to, ano ba ang ibig sabihin ng gradient? Kinukuha natin ang x component ay partial ng f with respect to x, and then ang y component partial ng f with respect to y. So with the corresponding corresponding component. Okay, so for the first component, partial x, so treat y as a constant. So y, and then e to the x, derivative ng e to the x is itself. And then for y, treat x as a constant, so we have a constant e to the x. Okay, so this is the gradient evaluated at 0,2, we get to e to the 0 is equal to 1. Yan. Okay. How about the vector u sa natin kukunin? Meron tayong given vector v, but hindi unit vector ang vector v. And you may notice na if you compute for the norm of v, this is equal to the ang norm ay negative 1 squared plus 1 squared. This is equal to square root of 2. So this is not equal to 1. So this is not a unit vector. So we need to normalize. And we normalize by multiplying with 1 over the norm, the original vector v. So we get a unit vector, negative 1 square root of 2, 1 square root of 2. Okay? So now, apply lang natin sa formula. So ganun lang. Therefore, the directional derivative of f at the point 0,2 is the dot product 2, 1 dot with negative 1 square root of 2, 1 square root of 2. So this is equal to negative 2 square root of 2 plus 1 square root of 2. This is equal to negative 1 square root of 2, or negative square root of 2 over 2. Okay, so again, technique natin sa pagkuha ng directional derivative. So that's 1A. About 1B. We have that function f of x, y is equal to x cubed plus xy plus y cubed. So let's start with computing the gradient. The gradient will be equal to ang x component f partial x. That is 3x squared plus y and then plus 0 kasi constant yung 3 tas constant yung y. Okay, and then f partial y ay x plus 3y squared. That's it. Evaluated at the point, anong point natin? Negative 1, 1. This is equal to 3 plus 1 is 4. And then negative 1 plus 3 is 2. Okay. So ito na yung gradient evaluated at negative 1, 1. And then next, U is a unit vector that makes an angle pi over 6 with the positive x-axis. So, anong pwede nating makuhang unit vector that makes an angle pi over 6? Okay, so let's say U is equal to, a vector with components u1 and u2. Okay, so you need to find the value of u1 and u2 such that the angle with the positive x-axis is pi over 6. Ano ba ang ano ba yung vector na magre-represent sa positive x-axis? We can choose I. Note that a vector in the same direction as the positive x-axis is vector v equal to I or 1, 0. Okay? And actually, this v is a unit vector. So using our formula for that product, 'di ba? Kasi merong involved na angle. So ang u dot v dot this is equal to norm ng u times the norm ng v cosine angle between them. So ang gusto natin na angle with the positive x-axis is pi over 6. Okay, so ang dot product nila ay di ba? U1, U2 dot product with 1, 0 equal to, ang norm ng 1, ng U is 1 kasi yan ay unit vector, and then ang V, yung vector na pinili natin in the same direction as the positive x-axis, is also a unit vector. So 1 lang din. And then what is cosine pi over 6? This is equal to square root of 3 over 2, no? Is that correct? Yes. Okay, so solving dito sa dot product natin, U1, mag-0 lang yung other add-in. U1 plus 0 is equal to square root of 3 over 2, which means U1 is equal to square root of 3 over 2. Now, kung U1 is equal to square root of 3 over 2, what is U2? Kailangan nasa-satisfy niya yung kailangan norm ng U is 1, di ba? So, since norm ng U ay 1, so square root ng U1 square root of U1 squared plus U2 squared, this is equal to 1. Means U1 squared, square root of 3 over 2 squared plus U2 squared, this is equal to 1. And from this equation, we can solve for U2. So this is equal to 3/4 plus U2 squared equal to 1. And then square both sides. So matatanggal lang yung radical. So and then we get U2 squared is equal to 1/4 U2 is equal to plus or minus 1/2. So we can get, we can take U to be any of either of square root of 3 to 1/2 or square root of 3 halves negative 1/2. Note na kung titingnan natin to sa 2D plane, no? Parang ganyan yung unit vector na makukuha natin. They are both pi over 6 degrees. They make both of them make pi over 6 degrees with the positive x-axis. Diba? Okay, so kahit alin dyan. So let's say ang pinili natin ay, so that's just a note, no? Na pwedeng kahit alin. So let's say we took U to be square root of 3 over 2 plus 1/2. So nasa-satisfy niya na this is a unit vector making an angle pi over 6 with the positive x-axis. Now therefore, ang directional derivative ng f at ano yung point natin here? At point negative 1, 1 is equal to the dot product na ano yung gradient na nakuha natin? 4, 2. And then this derivative, this is equal to 2 square root of 3 plus 1. Or if we take yung negative counterpart, ang makuha nating derivative ay negative 1. Okay, kasi dalawa yung possible. Okay, so try na natin ang C. Number 1, C. So for number 1, C, let's solve for the gradient ng F. Gradient ng F, component partial x is 2xy minus y squared. Okay, partial y is x squared minus 2xy. Okay, and then partial z is 3z squared. Now, yung gradient at the point 1, 1, 2, so this is equal to 2 minus 1, so that's just 1. 1 minus 2, negative 1, and then 12, 3 times 4, no? And then, yung vector natin V is the vector daw from P to Q. So that's 0, -3, -4. But note na this is not a unit vector since ang norm ay square root of 25 which is 5. So to normalize, kunin natin yung unit vector na 0, -3/5, -4/5. So therefore, ang directional derivative natin dito na gusto natin ay dot product ng 1, -112 with 0, -3/5, -4/5. This is equal to 0 plus 3/5 minus 48/5 is equal to -45/5, which is just -9. Okay? And then sa number 2, determine the maximum directional derivative at t. Give a vector along which this value is attained. So, according sa lecture video na napanood natin, merong result na ang max na makukuha nating directional derivative is given by the norm ng gradient along direction din ng gradient, same direction. So kung apply natin yung result na yan sa number 1, we have 1a. So that's yung max directional derivative is norm ng f of 0, 2 or norm ng vector na may vector here 2, 1. This is square root of 4 plus 1 square root of 5 along 2, 1. Then so 1b, so kailangan natin ng norm ng f at the point -1, 1. This is just square root of 16 plus 4. This is square root of 20 along 4, 2. And then sa C, norm ng nakuha natin gradient at the point 1, 1, 2. Norm niyan ay 1 plus 1 plus 144. This is square root of 146 along 1, -112. Now yung sa B, kung kukunin natin yung minimum directional derivative, according naman sa result na nakuha, ang minimum directional derivative is given by negative ng norm ng gradient. And ang direction, this is along negative ng direction ng gradient din. Okay? So, opposite direction. So, so tingnan natin yung minimum sa bawat na-solve natin so far. 1A, 1B, and 1C. So, minimum possible ay yung negative lang ng gradient evaluated at 0, 2. So that's negative square root of 5 along opposite direction, negative 2, negative 1, and then so 1b, this is negative square root of 20 along negative 4, negative 2, and finally, sa 1c, negative sa direction ng f, 1 ng gradient at 1, 1, 2. So this is negative square root of 146. This is along opposite direction. So negative 1, 1, and negative 12. Okay? So, yeah, that ends our exercises for this video, part 1 of part 2. So, see you in the next video for the second part. Thank you.